Okay, so we need to work a problem is what we need to do, and then it's going to look complicated, but you're going to love it because it's all laid out real clearly and in a straightforward way, so you're going to be okay with this one. All right, so but remember what we need. We need two things. We need a variance within the groups and a variance between the groups, and that forms the F ratio. Then we're going to take that F ratio that we got with our hard work, and we're going to compare it to the critical value that we get out of a table. We're going to look up the critical value on degrees of freedom between groups and degrees of freedom within groups, because F is a the ratio has to be positive. The critical value starts at 0, it ends at infinity. There's a cutoff with 5% if alpha is 0.05 here in the tail. And it's getting at any old differences. Actually, F is called an omnibus test because whatever kind of differences there are, something greater, something less, two things greater, two things, anything, it's going to pick up on any variability more than the variability that we would expect in the sampling distribution of the mean when the null hypothesis is true. It's going to pick up on any additional variability. So it's called an omnibus test. You just throw all the means in there and it'll tell you whether there's anything at all going on. But here's what I want you to know. We're looking for the variance between the group means. And I told you this a long time ago, but I'm not sure you remember it. But a variance, another word for a variance, is called a mean square. A mean square. And a variance is made up of two things, a sum of squares divided by degrees of freedom. So a sample variance is just, another word for it is a mean square, and it's a sum of squares divided by degrees of freedom. We've computed that a whole bunch. So we're going to have a mean square between groups, which means we're going to have a sum of squares between groups and a degrees of freedom between groups in our analysis of variance. We're going to have to find all those things. So we're going to have to find a degrees of freedom between groups, a sum of squares between groups. We're going to form the ratio of that to get a mean square between groups, and then that's going to be the numerator of the F ratio. Okay, same thing over here. We're going to form a variance within the groups. Well, a variance is just a mean square. But this one is a mean square within groups. And to get a mean square within groups, we need a sum of squares within groups divided by degrees of freedom within groups. So we're going to have to calculate, let's count them. We need 2 degrees of freedom and 2 sums of squares. And then we're going to form with those 4 things 2 mean squares. And then we're going to form with those 2 things the F ratio, the top of the F ratio and the bottom of the F ratio. So in our summary table where we're trying to organize everything, we're going to have a sum of squares between groups, degrees of freedom between groups, sum of squares within group, the degrees of freedom within group, mean square between group, mean square within group, and then F, and then we need to find the critical value for F. So let's do it. So I've kind of organized it already for you. So here's the degrees of freedom, and the degrees of freedom between group will go right here. Within group will go right here. And we need total, and the reason we need total is because it's just easier to calculate the total sum of squares and degrees of freedom and then get within group degrees of freedom and sum of squares by subtraction easier than it is to calculate those values directly. Because anything that we do within groups, we're going to have to do for each group. Well, if we do the total and we subtract between from it, then we get what's left over. And everything, all those numbers have 2 sources of variability. One is what's going on within the group. So the 5, 7, 8, how variable is that? The 4, 5, 6, how variable is that? That's variability within the groups. And the other variability is about the means between the groups. So the 5, 7, 8, the average of that, how variable is that from the mean of the ibuprofen group? How variable is that from the mean of the placebo group? So there are 2 sources of variability between groups and within. They both add up to this. So degrees of freedom adds up here, sum of squares adds up here. So we can get one of them or the other one by subtraction. So we're going to compute the total so that we can get the within group by subtraction without having to go within each group and compute it. Okay, so let's start with degrees of freedom. And we're going to start right here with total degrees of freedom. Total degrees of freedom asks the question, how many sources of information are there? How many pieces of information are there? Minus 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of information. Minus 1 is 8. So the total degrees of freedom is the total sample size minus 1. So 9 minus 1, so 8 degrees of freedom total. The between group degrees of freedom asks the question, how many groups are there? Minus 1. Well, we have aspirin and ibuprofen and a placebo. So we have 3 groups minus 1, so we have 2 degrees of freedom between groups. So this is the number of groups minus 1, so 3 minus 1, so 2 degrees of freedom between groups. Within groups, we can get it, like I said, directly from going within the groups and counting the degrees of freedom and adding them across the groups. Like, for example, this has 3 scores, so 2 degrees of freedom plus 2 degrees of freedom plus 2 degrees of freedom, so 6. Or we can get it by subtraction. We can say degrees of freedom total minus degrees of freedom between groups. And that's just easier. So 8 minus 2, so 6 degrees of freedom within groups. Okay, so sum of squares. We know how to get a sum of squares total. A sum of squares total is just the sum of all the scores squared. So we square all the scores and add them up. And then we add all the scores and square the total and divide that by the number of scores. So same old formula for sum of squares that we've been using over and over and over and over. So this, remember, we square first, then add. This, remember, we add first, then square. So I'm going to start you on it, but then I'm going to stop the video and let's see what you get separate from what I'm getting. How about that? So we're going to square the scores and add them up. So I can do that. So 25, 49, 16, 25, 36, 81, 64, 64. And then we add up all of that, and this is the sum of x squared. So the sum of x squared, let me just do it. Watch, I've got a calculator. Hang on, I'm going to do that part, and then you do the next part. The sum of x squared. Not now. Okay.